Welcome to our channel. Let's begin the journey.
Hey everyone, and welcome to episode 10 of... Today, we're going to completely challenge your everyday intuition about reality, and literally the ground beneath your feet. We're looking at how one of the greatest minds in human history, Albert Einstein, fundamentally rewrote the core rules of cosmology. So get ready, because we're about to explore a mind-bending reality that proves gravity, you know, the very thing keeping you in your seat right this second, actually doesn't work the way you think it does. Okay, let's dive into this. I want you to challenge a major baseline assumption for me. For centuries, mostly thanks to that famous legend of Newton's apple, we've just viewed gravity as this simple downward pulling force, right? Like a giant invisible magnet just tugging us toward the center of the Earth. But what if there's no invisible tether? What if gravity isn't actually pulling you at all? To really wrap our heads around this, we have to look at a massive, monumental shift in thinking that happened back in the early 20th century. Let's compare two wildly different views of our universe. Ever since the 17th century, Isaac Newton's mathematical formulas for gravity were the absolute gold standard, and they were highly reliable. But Newton himself notably never explained the actual physical mechanism behind how his gravity worked. It was basically just treated as this mystical, invisible pulling force that somehow acted instantaneously across vast stretches of totally empty space. Well, enter Albert Einstein. Through a grueling, relentless decade of wrestling with immensely complex geometrical equations, Einstein completely tore away that enduring veil of mystery. He argued that gravity wasn't a magnetic-like pull across nothingness, but rather the physical curvature of a flexible fabric. Now, to actually make sense of Einstein's grand vision here, we need to understand a truly revolutionary concept: spacetime. Einstein's theory of general relativity essentially stated that space and time are not these separate, static stages where the events of the universe just happen to play out. Instead, through his incredible imagination, he successfully unified three-dimensional space and one-dimensional time into a single, unified, flexible, four-dimensional fabric. Think of it kind of like the ultimate operating system of the cosmos, a tangible, physical grid that literally everything in the universe rests upon. Let's get a bit more tactile with this. Imagine you're holding a giant, tightly stretched trampoline. That trampoline is space-time. Now, what happens if you take a massive, really heavy bowling ball and just drop it right in the center? It sinks, right? It physically stretches and curves the fabric downward. Well, this is exactly what Einstein formally showed. Gravity is absolutely not a mystical pulling force. It's simply the physical curvature of the space-time fabric. Extremely massive objects, like our sun, for example, create these deep, sloping dents in the spatial framework. So what does this actually mean for us here on Earth? Well, if you roll a smaller marble onto that trampoline with a heavy bowling ball sitting in the middle, notice how it doesn't just zoom straight across. It curves inward, spiraling along that slope. Earth isn't being magically tugged through empty space by some invisible rope attached to the sun. Not at all. It is simply gracefully sliding along the invisible, natural curves of that massive dent created by the sun's overwhelming mass. We're really just following the curved geometry of space-time. And this brilliantly illustrates the entire concept, which was perfectly crystallized by the physicist John Wheeler years later. He said, "Matter tells space-time how to curve, and space-time tells matter how to move." It's such an elegant, breathtaking summary of Einstein's complex mathematical masterpiece. The mass of the sun literally tells the fabric of space how to bend, and then that resulting bent path dictates exactly how the Earth moves around it. But, you know, here is the massive roadblock that Einstein faced. How do you actually prove this? I mean, how do you prove an invisible four-dimensional fabric actually bends? The scientific method demands that science never operates on pure belief alone. So no matter how incredibly beautiful and mathematically elegant Einstein's general relativity was, without empirical real-world observational proof, it firmly remained just numbers and equations on a piece of paper. The theory desperately needed a definitive test to verify that physical mass truly bends the fabric of space. Which brings us to a really high-stakes historical drama. The ambitious man who eagerly took on this historic mission was Arthur Eddington, an exceptionally brilliant British astronomer. And keep in mind, he was doing this in a deeply fractured world that had just endured the unprecedented bloodshed of the First World War. Despite all of that, Eddington bravely organized a daring, highly challenging scientific expedition to the remote island of Principe, located off the coast of West Africa. His goal? To photograph a total solar eclipse in May of 1919. Eddington's scientific goal was crystal clear. If Einstein's radical theory was right, the colossal, overpowering gravity of our sun would physically act like a giant lens. During the eerie darkness of the eclipse totality, when the sun's blinding glare was finally blocked out by the moon, Eddington wanted to photograph the stars positioned directly behind the sun. See, if space-time was actually curving, the ancient light traveling from those distant stars would be forced to travel along that curved path, ultimately causing their apparent visible positions in our sky to shift slightly from where they normally should be. Now, what's really interesting about this slide is that when Eddington successfully executed his meticulous data analysis, one specific number stood out above the rest: 2. The ancient starlight was indeed bent, but not just bent, it was bent by the exact, precise amount predicted by Einstein's geometrical equations. And crucially, that was exactly twice the amount predicted by classical Newtonian physics. Just like that, Einstein's bold claim was completely empirically validated. He literally became a global icon virtually overnight. But beyond the staggering physics here, there's a profoundly poignant human element to the story that we really cannot ignore. This monumental discovery wasn't just a massive triumph for the field of science, it was a beautiful, completely necessary moment of healing for the battered human spirit. Just think about it for a second. A British scientist worked tirelessly, organizing a dangerous expedition specifically to prove the theory of a German scientist right after the devastating division of the First World War. It affirms so beautifully that the pursuit of truth fundamentally transcends earthly borders and our petty conflicts. Einstein's general relativity was far more than just a brand new theory of gravity. It effectively became the absolute foundation, really the central core operating system of all modern cosmology. Just think about the phenomena we study today: the rapid expansion of the universe itself, the violent, devastating birth of black holes, the incredibly strange way that light is physically bent by mass. All of these things are the direct, inevitable consequences naturally born from the beautifully elegant foundational equations of this one man. And that leaves us with a thrilling, almost haunting final thought to wrap up this explainer. If the math of general relativity is truly the blueprint of reality, what terrifying monsters are lurking deep in the cosmos? Because hidden right within Einstein's equations were predictions of regions of space aggressively collapsing into blind spots that devour and swallow light entirely. Black holes. These were accurately predicted mathematically by brilliant minds long before human instruments could ever hope to see them. Gravity isn't just holding us down. At its most extreme, it's literally tearing holes in the fabric of reality. Now that your intuition is completely challenged, I hope you're hungry to explore more of these dark cosmic mysteries.
The view from here is breathtaking. Command, we are in position and ready for the next phase. If you liked the video, subscribe and comment the topic you want next. Thanks for watching, and stay unstoppable.